Hello grade 12s. The purpose of this video is to take you through your measures of spread, the Box-Whisker plot, and specifically to go through the assignment that you were given on the Box-Whisker plot. So let's first revise some concepts. If you're looking at a data set, the first concept you need to be aware of is where is the median of that data set, and that is your middle value. It splits your data into half. 50% of the values in your data set lie below the median, and 50% of your data set lies above. Your next concept is that of your quartiles. Your quartiles split your data set into quarters. So, for example, the lower quartile or the first quartile splits your data set such that 25% of the values in your data set lie below it, and 75% of your data values lie above that first or lower quartile. Your second quartile is none other than your median. It is where 50% of the data set lies below that quartile and 50% lies above it. And then your third quartile splits your data set such that 75% of your data set lies below the third quartile and 25% lies above it. The next concept is that of your interquartile range. And this is the spread of the middle 50% of your data. So how are we going to work out where the middle 50% is? Well, if your median represents the middle of your data set, and the third quartile represents 75% of your data set, whilst the first quartile represents 25% of your data set, then obviously the middle 50% is going to lie between these two observations. In other words, your interquartile range lies between your third and your first quartile. It is your third quartile less your first quartile. And it gives you an indication of the spread of your data because it represents 50% of your data. Next up is your percentiles. And if your quartiles split your data set into quarters, then obviously your percentiles will split your data set into percentages. And specifically, it gets split up into 100%. So your first percentile will represent where 1% of the data falls below that number and then 99% falls above it. Your 10th percentile shows that 10% of the data falls below that number and then 90% falls above that number, and so on. Your 25th percentile is none other than your first quartile, because that represents 25% of your data set to the left of it and 75% to the right. Your 50th percentile is your median, meaning 50% of your data lies below the median and 50% lies above. Your 75th percentile is also your third quartile. Just to give you a real-world application, I'm not sure if you've heard of a group in America known as We the 99. And now what this represents is the 99th percentile in the US in terms of population. So what is that saying? That is saying that 99% of the American population falls below this 99th percentile, and only 1% of the population falls above that percentile. And so these people who are part of the 99th percentile mean 99% of the population, 99% of the people in America earn less than 1% of the income in that country. So now moving on to your Box-Whisker plot, which uses these concepts that we've just revised. Your Box-Whisker plot looks fairly complicated when you sort of glance at it on a page, but actually if you know what it's made up of, it's a very neat tool. So first of all, you have your box. with a line straight down the center. It need not be in the middle of the box, but there will be a line through the box, and that represents your median, your middle observation. The line making up the right-hand end of the box is your third quartile, and the line making up the left-hand end of the box is your first quartile. Then you have got two whiskers, and they can be of varying lengths. They may not always be equal lengths as I'm drawing them here. Your whisker ends with a line that represents your minimum value in your data set, and your right-hand whisker ends with a line that represents your maximum value in your data set. And this Box-Whisker plot, therefore, visually represents what is known as the 5-number summary of a data set. Excuse the handwriting. And some important or interesting things you can see in this Box-Whisker plot, first of all, is that the box accounts for your middle 50% of your data set, which is also known as your interquartile range. Remember, the interquartile range is from Q3, or rather from Q1 up to Q3, or it's Q3 minus Q1. So that is your interquartile range. And each component, the distance between each component represents 25%. The distance from your minimum up to your first quartile represents 25%, or a quarter of all of your observations. The distance between quartile 1 and the median also represents 25%. And from median to quartile 3, 25%, and from median to maximum represents a quarter of your data set. So moving on to the assignment that you had to do on box and whisker graphs. So the first question was not in fact a box-whisker chart at all. It was just a bunch of different types of bar graphs. And what we gave you were 3 different bar graphs showing your population spread across the provinces in South Africa. So your first graph, graph A, shows you your population spread across 4 different age groups for each province in South Africa. And this is a multiple bar graph because for the Eastern Cape, you have your 4 age groups and the population spread. And then you have the same for the Free State and etc., etc. This is known as a multiple bar graph. Your next graph, graph B, is a stacked bar graph showing you the same information, the number of people per province per age group. However, now it's a little bit harder to read exactly how many people in the Eastern Cape are aged 0 to 14 versus over here. There's your 0 to 14 in your Eastern Cape. Then you also have to be able to read how many people are aged 15 to 34 in the Eastern Cape versus this value over here. So it's showing you the same information, but your information has just been stacked on top of each other for each province. Your last graph is another version of a stacked bar graph, but this time using percentages. So all of your data must add up to 100%. And this shows you that in the Eastern Cape, approximately 32 or so % of your population is aged 0 to 14. And you then have to go and read against your axes how many percent approximately are aged 15 to 34 and 35 to 64 and then 65 plus in the Eastern Cape. And that is done for each of the provinces. So question 1.1.1 asks you to explain the difference between graphs A and B. And we've kind of already explained it. Graph A is a multiple bar graph and graph B is a stacked bar graph. And how you can explain that is you could say graph A shows you each age group and the total of each age group in each province, whereas graph B shows you the total population in each province, and that is then split up into the different age groups in one single column. You could also go on to say that there is 1 column per province in graph B, where there are 4 columns per province in graph A. The next question asks you, which graph would you use to determine which province has the highest number of residents over the age of 65? So let's go and have a look at these graphs. Which graph is going to make it easier for us to see the province that has the most number of pensioners over 65? So if we look at graph A, it is going to be the bar on the extreme right in each province. Okay, so it looks fairly easy. We just need to look for the province that's got the larger or the higher bar. And it seems to be KZN for interest's sake. In the next graph, if we look at graph B, how are we going to tell which province has the largest number of pensioners? So your pensioner group is going to be the group that is at the top of each of these columns. Now, it's quite hard to see which of these columns has the broader or the thicker little white bit at the top for your pensioners. So I wouldn't say graph B is going to be any easier than graph A. Then let's have a look at graph C. Over here, once again, this is going to tell you which province has the highest percentage of people who are 65 and over. If you look at each of these little tips at the top of each column, that is going to tell you which has got the largest percentage of pensioners, but it's not going to tell you which has got the largest number as per the question. We need to find out which has got the highest number of residents. So your answer is going to be that it's graph A, as we just saw, and for the simple reason is that it's easier to read off that graph. Your next question asks, which province has the lowest percentage of 0 to 14-year-old residents? Does this mean that it has the least number of 0 to 14-year-old residents in the country? So it's going to be very important for you to choose the correct graph to draw off. We want to know which province has the lowest percentage. So we're going to come up to our graphs. You should already have a clue that you're not going to look at graph A, because that is showing you the number of people per age group. We want to have a look at the graphs that are talking about percentages. Graph B also looks at your number of people by age group. We're going to come down to graph C, and we want to know which province has the lowest percentage, so that's why we're looking at graph C, of 0 to 14-year-olds. In other words, which province has got the smallest black bit at the bottom of its columns here. So if on your script, you would have printed out most probably, or you can put a ruler up to your screen if you didn't print it out, which of these black bars ends at the lowest point. And that is over here by a small margin. It's in Gauteng. So the first part of your answer is that Gauteng has got the lowest percentage of 0 to 14-year-olds. Does this mean that it has the lowest number of 0 to 14-year-olds? Well, you can check yourself by coming up to the top graph to have a look. Here is the number of 0 to 14-year-olds in Gauteng. So the answer is definitely no. By no stretch of the imagination does it mean that Gauteng has got the least 0 to 14-year-olds. In fact, it's got the second most 0 to 14-year-olds. But what this is telling us is that this number of 0 to 14-year-olds makes up the smallest proportion of the entire Gauteng population, made up by each of these 4 columns here. So your answer to question 1.13 is that Gauteng has got the lowest percentage of 0 to 14-year-olds. And no, this does not mean that it has the least number of 0 to 14-year-olds. It just shows you that when you convert that into percentages, the 0 to 14-year-olds or the children make up the smallest proportion of the total population for all the provinces. Question 1.1.4 asks, which 2 provinces have the most 15 to 34-year-old residents, and estimate the number of residents in these provinces? Excuse that typo over there. So you need to now go and have a look. Which graph are you going to use? Well, the clue is in the fact that we need to estimate the number of residents. So we know we are not going to use the percentage graph. We're going to use one of these 2 number graphs. So where is it? We've already answered in question in question 1.12, that the easiest graph to read off, we already said over here, was graph A, because it's just easier to read off. So let's use that answer to come and choose which provinces have got the most 15 to 34-year-olds. So we are looking for the column graph of that medium gray. So it's that column there in the Eastern Cape, Free State, Gauteng, KZN, etc., etc., etc. I don't need to carry on. You can see the two tallest of these medium grey graphs occur in Gauteng and KZN. And that shows you the total number of people in this age group in each of those provinces. So our first answer, or the first part of the answer, is that the two provinces with the most 15 to 34-year-olds are Gauteng and KZN, KwaZulu-Natal. And roughly how many residents are there in these provinces that are aged 15 to 34? Well, you just have a look. But swinging across to your vertical axis, these two graphs appear to peak around 4 million people. Question 1.2 is based on a World Health Organization graph for the treatment failure of a malaria drug in a selection of 6 African countries. And what you are looking at here is a Box-Whisker plot. So before we answer any questions, let's just talk about what this graph is showing us. On the horizontal axis, we see the proportion or percentage of the cases that showed failure to the malaria drugs. So if we take a look at Rwanda, for example, remember what a Box-Whisker plot shows you? Here the box is showing you the middle 50% of all of the malaria cases. The median shows you where the middle of your entire data set is. Your entire data set runs from the minimum to the maximum. So 50% of all malaria cases fall below this proportion of roughly, say, 13%, meaning in 50% of your cases, treatment failure is 13% or less. Your minimum value is roughly 7%, showing that your least efficient or your most efficient treatment is that there was only 7% failure in that case. And over here, your worst case is that there was 40% failure to respond to the drug treatment. So that's what a Box-Whisker plot is showing you. Your first part of the question is asking, what is the upper quartile proportion value for Zimbabwe, and what does this mean? So let's have a look at Zimbabwe on the graph here. The upper quartile, remember what that is? That is the third quartile. And which value is that in your Box-Whisker plot? Remember, this is your Box-Whisker plot. Your upper quartile or your 75th percentile, your upper value, is going to be here at quarter 3, which is represented by the right-hand edge of your box. So in Zimbabwe's case, here we are looking at the upper quartile proportion. What does it correspond to? We bring down here to the horizontal axis. It corresponds to roughly, we'd say not 5%, but probably 4%. And what does that mean? It means that this is the upper quartile, so in other words, the 75th percentile. It means in 75% of cases, the failure to the malaria drug was less than 4%. The next question asks, which country has experienced the most success for malaria treatment, and justify your answer. So what we're going to do is we're going to come up and have a look over here. So if we're looking for the most success, we're looking for the country that has got the lowest proportion of failure, because this axis here represents proportion of cases that did not respond to malaria medication. So in other words, there was failure. So the higher you are up on this axis, that means the higher proportion of your cases failed to respond to treatment. The lower you are, that shows you the least number of cases failed to respond to the treatment. So we're looking for a country that has got a Box-Whisker that is very low down on this horizontal axis. So we're going to come and have a look. We're looking at Zimbabwe for one of them. Let's have a look at the Comoros. So your Comoros shows you that approximately 3% if you look at this as their upper quartile, it's also, they don't have a whisker over here. Okay, have a look there. They don't have a whisker, which means that that upper quartile is in fact also their whisker, their maximum value. So it's showing you that this upper quartile, this maximum value, corresponds to roughly 3%, which means that in all cases, your failure to treatment is less than 3%, which is better than Zimbabwe, which we answered in the previous section that showed us 75% of cases had a failure rate that was less than 4%, which is pretty good, right? But the Comores is just a pips Zimbabwe because it is sitting with a failure rate of less than 3%. So it would seem that the Comores Box-Whisker plot shows us that the proportion of failure to the treatment is less than 3%, making it the country with the most success. Then your last question about box whiskers asks you, in which country was the median value approximately the same as the minimum proportion in Rwanda? So this is actually relatively simple. It just is testing, do you know what a box whisker plot represents? So we need to come across to Rwanda and look for its minimum value. Remember, which is its bottom whisker. And we need to look and see in which of the other countries does this minimum correspond to that country's median. And remember what the median is? It's the line that is going down through the box. And here we can see that Eritrea's median is roughly at the same place as Rwanda's minimum. So your answer will be Eritrea. Question 1.3 now presents you with some data in a table format. It's the number of fatal car crashes per month for two sets of years, 2017-18 and 2018-19. So what you first need to do before you go and answer any questions is acquaint yourself with the data. You have got the months running from April to March. So this is a fiscal year. And you've got car crashes per month for the 2017-18 fiscal year and then for the 2018-19 fiscal year. And the idea is for you to compare. Has there been an increase or a decrease over the 2 years for the corresponding months? Then question 1.31 asks you, which month has the highest number of fatal car crashes in both years? And what do you think the reason is for this? So what they would be asking you to do here is to take a look at your data and look for the maximum value in each year. So if you come down your first column, you would have needed to place this data, or rather rank this data from highest to lowest. Your highest is obviously 1,090. And over here, same thing, obviously 1,070 is your highest. And they both correspond to December. And so the answer is December had the highest number of fatal car crashes. And this has probably got to do with the fact that this is your peak holiday period in South Africa, where there are a lot more cars on the road. And also you've got a lot more people a bit jovial, especially around Christmas and New Year, perhaps driving under the influence. Your next question asks for a number of measures for the year 2018-2019, namely the minimum, the 3 quartiles, 1, 2, and 3, where quartile 2 is your median, and your maximum. In other words, you are asked for the 5 numbers that make up the box-whisker plot for this data. Now, in order to complete this, you need to order your data in such a way that it runs from minimum to maximum. So what I've done, we needn't have done it for the year 2017-2018, but I've done it anyway, where you have ordered your data from the minimum value to the maximum value. But just please take note, I have just used this table, the rows in this table, as a guideline. Note that this value here of 760 does not correspond to April. In fact, that value of 760 corresponds to February. Okay, so I've just written these numbers in the table just for the case of showing it to you here. So let's get down to the question. We need to find the minimum value for the 2018-2019 fiscal year. And because I've gone and saved myself the trouble by ordering my data, my minimum value is going to be 750, and I may as well get my maximum while I'm here of 1,070. So that is what I will fill in for A, 750, and my maximum is 1070. Then I need to find my 3 quartiles, first, second, and third quartile. So remember, what is your median? Your median value is the number that splits your data set into 2. So we sit with 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 months. So you are not going to find a clear and easy median because you need an odd number of data points to get a slap bang in the middle number. Your median is going to fall somewhere over here between the 6th and the 7th observation. And what is your formula or your tool for working out the median? You take 880 plus 920 and you divide it by 2. And 880 plus 920 gives you a value of 1800. You divide that by 2 and you will get a value for your median of 900. Next up, we need to find the first and the third quartile. So in order to do that, I apply the same principle as I did for the median. So remember where my median is. It's over here, and it's equal to 900. Now, my first quartile is going to split this first 50% of my observations into 2. And once again, I sit with an even number of observations. I sit with 6 observations. So my first quartile is going to be there in the middle. Now, I'm fortunate in the sense that I've got a double or a repetition here. I've got 840 followed by 840. So the average between those two numbers is obviously also 840. So I'm just going to write over here, nice and easy. My first quartile is 840. My third quartile, I need to split this second 50% into 2. And that happens here between 960 and 970. What do I need to do to work it out? I need to work out the average between those two values. So 960 divided by, or plus 970 divided by 2 is going to give me my value of 965. And that is my third quartile. That's where I got that value from. The last part of this question asks, in 2017 or 18 and 18, that's the first column, which measure of central tendency, either mean, median, or mode, is going to be the best description of the average number of fatal crashes, and explain why. So, if we come up to our table, what is our mean? That is the average of all of these crashes here in the first column. Median is going to be my middle number somewhere over here. And mode is going to be the number that appears the most. So where I have repetition, which is over here in at 960, that is my mode, because that number appears twice, whereas all my other numbers only appear once. We can scratch mode out already, because mode is not going to tell me what the average number of fatal car crashes for the year was. It's just going to tell me which months had the same number of car crashes. So mode, we're going to scratch out. The question now is, do we use mean or do we use median? So the answer has got something to do with the fact that you've got quite a big outlier over here at your maximum. If you have a look at all of your other months, there are very minor incremental increases from month to month. There's an increase of 20, increase of 80, increase of 60, increase of 10, increase of 20, 40. Whereas over here, we've got an increase between February and, or not between February and March, between the two, the maximum and the number below it, you've got an increase of 110. So this we can regard as an outlier. The problem with your mean is that your mean is going to be skewed towards the higher values because of this outlier. So therefore, we will rather use our median, which is going to fall between 910 and 950. Your last question presents you a Box-Whisker Plot explaining the Sunday concerts that the Witwatersrand Botanical Gardens hosts in summer. So you've got box-whisker diagrams representing the ages of attendees to two different musicians. So that there is your age on your horizontal axis. One concert features a well-known rap artist and the other features a jazz musician. And you need to use the diagram to answer the questions that follow. So what I did over here by drawing this axis in, it's very important for you. You need to make sure that you understand your graph before you even start answering the questions. So you need to know that on the horizontal axis, you're talking about age. So your Box-Whisker plots, remember what they're going to show you. They're going to show you the median age over here for each of the different concerts, the maximum age and the minimum age for each of these concerts. So, question 2.1 asks, which concert do you think is represented by the data from the first diagram? So, diagram A. Do you think it is representing jazz or do you think it is representing rap? Now, what we need to do is we need to have a look. First of all, let's look at the spread. Your people who are attending this concert are aged 0 to 50. The oldest person who came to this concert is 50. The median age is roughly 25, which means half of the people who are attending this concert, half of them are less than age 25. Your other half of your concert goers, your top half of your concert goers, are aged between 25 and 50. If you have a look at the second diagram, your maximum age is around 74 and your median age is around 50, which means half of your concert goers are aged between roughly 7 and 50, but more importantly, half of your concert goers are aged between 50 and 75. So it makes sense that you are not going to have a bunch of 50 to 75-year-olds at a rap concert, right? You're rather going to have a bunch of 25 to 50-year-olds at a rap concert. So it makes us think that diagram A is the rap concert. The next question asks, if there were 5,000 people at the concert represented by diagram B, how many people were over the age of 33? So diagram B is your jazz concert, remember, because A is obviously your rap concert. So if diagram B is your jazz concert, how many people are over the age of 33? So now where does 33 come into this thing? If you come over here, 33 represents the bottom of the box of your Box-Whisker plot, which is represented by quartile 1. So that means 25% of your people are less than 33 years old and 75% are older than 33. So we have been asked how many people are over the age of 33, and we know that that is 75% of our sample because it is represented by the first quartile. So we then need to just work out 75% multiplied by 5,000. And the answer you're going to get is that 3,750 people are over the age of 33. Your last question asks you which concert appeals to more people of all ages. Explain your answer by referring to the diagram. So what we want to know is we want to know which of the two Box-Whisker plots has more of a spread, because we want to look at how many people of more ages are involved in that concert. So I've cleaned up these Box-Whisker plots a bit. So now we need to check which of the two, rap or jazz, appeals to more people of all ages. So there are a number of ways you can go about looking at this. You can look at the size of the box. So your middle 50%, how spread out is your middle 50%? Rap has got a much narrower spread from around age 20 to say age 38. Jazz has got a wider spread from 33 roughly to around 59. You can also look at the measure of spread from your minimum to your maximum. You've got a spread of around 67 for jazz. Rap, you're looking at a spread of just over 50. So it doesn't actually matter how you explain it, as long as you just tell me in one way or the other that the jazz concert seems to appeal to more people of more ages because of its wider spread. Whether you told me about the difference between the first and the third quartile, your interquartile range, or whether you told me about the spread between maximum and minimum. But the answer is that jazz has got more appeal. And that, grade 12s, is the end of this discussion on Box-Whisker plots and your measures of central tendency.